In this lecture, we will be discussing about solving the systems of linear equations. Consider a linear system given by the set of equations a11x1 plus a12x2 up to a1nxn equal to b1 and a21x1 plus a22x2 up to a21xn equal to b2. Similarly, in a generalized way, am1x1 plus am2x2 up to amn xn equal to bn. Using the matrix equation, we can solve this linear system by writing the matrix equation as ax is equal to b. Here, A can be represented as a matrix and all the elements of this matrix is formed by the coefficients from this linear equations. That is, matrix A is equal to a11, a12 up to a1n. Similarly, am1, am2 up to amn. And matrix X, elements of matrix X are the variables x1, x2 up to xn. Forms the matrix X, and b1, b2 up to bn forms the matrix B. That is all the elements towards the right side of the linear equations forms the matrix B. And we can classify the system based on the solution. If the system has a solution, then the system of linear equations is said to be consistent. And if the system has no solution, then the system of linear equations is said to be inconsistent. And the consistent system, that means it has a solution. Solution can be of two types. One, unique solution, another, infinitely many solutions. A consistent system can have either a unique solution or infinitely many solutions. Theorem: a non-homogeneous system of m linear equations with n unknowns represented by ax is equal to b is said to be consistent if and only if the coefficient matrix A and the augmented matrix AB have the same rank. That means the system of linear equations is said to be consistent or having a solution if and only if the coefficient matrix A and the augmented matrix AB both have the same rank. In particular, consistent equation. If rank of A equal to rank of AB, then the system of equations are consistent. And in particular, unique solution if rank equal to n, where n is the number of unknowns. If the rank r equal to n, that is the number of unknowns, then the system will have a unique solution. And if rank is less than the number of unknowns, if the rank r is less than n, that is the number of unknowns, then the system will have infinite number of solutions. That is, n minus r unknowns can be assigned with arbitrary values. If rank of A is not equal to rank of AB, then the system is inconsistent. That is, there will be no solution. We can look at an example. Check for consistency of the system of equations. 2x plus 6y equal to minus 11, 6x plus 20y minus 6z equal to minus 3, and 6y minus 18z equal to minus 1. Check if the system of linear equations is consistent or not. First step is to represent using the matrix equation, that is ax is equal to b. Therefore, we can write the matrix A, which is formed by the coefficients of the linear equations from the LHS part. That is 2, 6, 0. Since there are three variables, x, y, and z, and in the first equation, it is 2x plus 6y in the LHS of this equation, and the coefficient of x is 2, coefficient of y is 6, and coefficient there is no term for z. Therefore, the coefficient of z is 0. Similarly, 6, 20, minus 6. Here no term for x, so we can take the coefficient as 0. 0, 6, minus 80. This is matrix A. And matrix X contains all the variables x, y, and z. And matrix B is formed by the elements towards the RHS of the equation. Minus 11, minus 3, minus 1. Then our matrix equation is Ax is equal to B. Therefore, we can substitute the corresponding matrices and write it in the equation form. Our next step is to find the augmented matrix. Augmented matrix AB is found by just combining the bth column, this bth matrix, as one more column towards the matrix A. Just appending the matrix B towards matrix A. This is the augmented matrix. Now simplify this matrix using row reduced echelon form. Using row reductions, simplify this augmented matrix to find the rank. For that, use the row transformation. R1 gives 1 by 2 R1 to make the first element of the first row as 1. Then the first row gets updated as 1 by 3, 0, minus 11 by 2. Now we have to make all the elements below this one to zeros. So use the row transformation. R2 gives R2 minus 6R1. Next step, we have to make the second element of the second row 1. So use the row transformation. R2 gives 1 by 2 R2. Next make all the elements below this one to zeros. For that, use the row transformation. R3 gives R3 minus 6R2. This is the simplified matrix, and we can see that there are 3 non-zero rows. Therefore, rank of matrix AB. Rank of AB equal to 3. From here itself we can find the rank of matrix A, because we have formed this matrix AB by appending the matrix B with this A. So for finding the rank of matrix A, just ignore this column. Just ignore this column. Then we can see that the simplified matrix contains 2 non-zero rows. For matrix A, the simplified matrix contains, or reduced matrix contains 2 non-zero rows. Therefore, rank of A equal to 2. Since rank of AB not equal to rank of A, the system is inconsistent. We can see the rest of the problems in the next class. Thank you.